We chatted about logarithms last week. We chatted a little bit about what these would look like when we were trying to get to a solution. So, for instance, we said before, what this question was really asking us here was, whatever my base is, and it's kind of hard since they're the same thing, we're going to do it with numbers in a minute. But my base to what power gets me this value? We always said, this is my base, this is my answer. So what could I take, what power could I take B to get B back? You're like, wait, what? Okay. Let's use numbers instead. 2 to what power would get me 2? 1. So in this case, B would have to be 1. That's the only way this is going to work. So if you ever see a base value and a number that are the same, that answer is just 1. Which seems kind of strange, but you're like, okay. Or, if I get, ooh, nice, got it already. B to what power gets me to 1? Well, anything to the power equals 1. Oh, let's go. Let's shrink a little. There we go. Now we might actually make it. All right. So that was more like way behind basics. These are more of what we were starting to look at. So, okay, product rule. If you're multiplying, we are going to add, just like we do with exponent rules. So when you see the times, that becomes plus. And we'll get that in there. So, here's the thing though. Depending on which thing we're doing, it depends on which direction we go. So for instance, multiply to add to multiply. If I'm being asked to condense or smash this down, and it's plus in the middle, that's going to become times. So we're going to have log, can't lose my base, and when I start writing this, when I get to the plus, that's when the multiply part comes in. And notice we went from 2 logs down to 1. And so here, my final answer, if I'm being asked to condense, so my log base 5 doesn't change at all. The only thing that changed was that plus became multiplied with 2 of values, our larger numbers, which is simplified numbers. Whereas if we're trying to make it wider or expand, okay, I want to make note on here that there's many possible answers to this, because if I'm trying to expand this, I'm trying to get this to a point. I got to have 2 numbers that multiply to get 63. Any 2 numbers, there's lots of options. 9 and 7 would be a good choice. And so now expand means we're going from 1 log to at least 2, and that's what we're doing in this case. So we're going to start writing this, and when we get to the multiplication dot, it becomes addition, okay? We're just going from this to this. And so once you put the plus in, we write the log again with the second number, because expand means more than 1 term. So in density, you're only going to have 1. Sure. So that's where the whole get bigger, get smaller is going to come from. And it's going to happen with this quotient rule as well. Here, divide is going to become subtract. So if we're being asked to condense something, there's the infamous minus sign like we had the plus up here. And condense again means we're going to get to one single logarithm. And we're just going to take the two values that are given, and it becomes divide. Minus to divide when we're going the condense way. And if you'd left it like that, I mean, I wouldn't be upset because you got the right. But this actually reduces 84 divided by 12 is 7. So this is better. That would still be good. You would be showing me that you knew what was going on with that. That's showing me you know that condense is going from subtract to divide. Are you saying if you knew that, it could just go to straight here?
No, what I'm saying, instead of like doing like a bar, like a numerator and denominator, if I just did like 84 and the divide symbol.
It'd still technically be the same thing.
I just want to make sure it wouldn't lose.
Yeah, nope, it would not. And so if we're going to expand kind of in that same odd way, now I need, oh boy, two numbers that if I divide them, the answer is 9. 81 and...
2. Or no. Wait.
It's like, dang it. I'm with you on your 81.
81 is on.
81 and 9.
Correct.
Yeah, 18 and 2 also would have worked. Either of those work good. And then so again here, we're stretching this, we're expanding this. So here I would have log of 81. The division becomes subtraction. We stretch that out. And so these last two, the power rule again meant we were going from exponent to coefficient and back and forth here. Again, I know we're real abstract with a lot of the stuff that we're putting here right now, but again, we get the numbers in a little more concrete over here to the right. And so here, anytime we see that number in front, that coefficient, it's going to come up and turn into an exponent on our of value. And then if that can be simplified, and since they're numbers, we can. 8 squared, not 8 times 2, but 8 times 8, would get me smashed down to my one term that we're looking at. And so it all does. It just depends on where that first piece is. Like here, I don't have a coefficient. I don't have a number in front, but I've got this exponent this time, so I'll bring that to the front. And at this point, you'd actually have a choice. You absolutely could just leave this way, and I'd actually prefer that you do, because if we distribute right now, you're going to think it's a division problem, because you're going to see the minus in there. So if you have an exponent that's got multiple parts going to it, or a coefficient, just leave it that way. That's, again, why I'm glad we're kind of getting this in here to make this a little bit easier. But I do have one new thing to share today. So we've been doing change of base before, where we had to type in 2 different logs. So we do the log of A divided by the log of B. So when I got over here, we do the log of our of value, the 32, divided by the log of my base, and I don't know that off the top of my head. So we got to fix this. because we're going to get something decimally. Usually we just go to like 3 decimal places. If you're worried you're going to forget how to put that in, there actually is a faster way on the calculator, because I've been playing around a little bit. So if you want to do this the fast way, if you go to math on the calculator here, math, and you go down, you're going down a ways here, math A, which says log base. You can type it in exactly the way you see it in, log base, the way you see it in the problem. Because once you hit enter, you can see, oh, so I can do like 732, okay? You can't do that any other way unless you do change a base. The 2 ways you see on here are the 2 ways you can get the right answer. You can't write like log 732. It's not going to think that it's the same thing. So both of those will work. It's totally your call on how you go about doing them. So, like I said, I went a little bonehead. The assignment ended up in the notes, which, like I said, going to be good for you if you do this the right way. And so I'll put this back up in a minute if we need to go back there. I want to jump in, since this is actually the practice, and I want to make sure, I'm just looking at a couple of these and seeing what we're going to get into. Ooh. Okay, that's cool. I'll do an easy one and a messed up one with you in each of the sections here, just to make sure that we're on the right track. Okay. So on page 10, and I can zoom back. Oh, no, go that wrong way. There we go. So here, and I'm going to keep pulling my notes back over here. Rewrite is a single logarithm. Okay. First thing I notice is that there's coefficients. If there's power rule stuff going on, we want to deal with that first up here. Okay? So I'll even write that. So if there's coefficients / exponents, we're going to do that first. So swing those around. And they are becoming exponents instead of being coefficients. Okay, that's just the first part. Then I notice if you have any product rule going on, if there's any adding that needs to turn into multiply, that's going to be the next thing that I do. So now we get to start actually condensing and smashing this. So we've got log 4, a to the 4th, the add becomes multiply, b squared. Now, if at this point I did have subtract or divide, that would be what I finished off last. But I don't this time. So that actually was the answer. I was done. I'm down to one single log, just playing with those. I don't think I can condense that anymore because I've already got this to multiply. So if I
just do like a to the 4th, b to the 2nd.
Yeah, it's the same as having the multiplication dot there. Yeah, you could just have a to the 4th. You don't have to have the multiplication dot, no. Nope. Now this one's a little weird. You're like, okay, so how does this work when this 1/3 is in front? Personally, this is me. I don't like getting into the exponent game with this. So when I see parentheses, I usually distribute first. So that 1/3 is going to become your coefficient on both of these. Could I have done this in a faster way? Maybe. But at the same time, we want to do this the right way. And so once those parentheses are out of the way, and I kind of start to look up at number 20 a little bit, I'm like, okay, so these 1/3 are going to become exponents, and Hardy needs to learn how to write smaller. We're going to be all right. So both of these 1/3 become exponents on their of values. And here's where it starts to get a little bit interesting. I'm going to try, like I said, I'm going to try and write smaller now. Make sure you can see everything we're up to. So power rule, check. Product rule, do I see any adding? I do. That's what needs to come next. So we're just going to deal with this. Now, if you wanted to with these, since they're numbers, you could try to simplify them. I'm not worried if you do or if you don't. But these two I just smashed down into one. We're almost there. And so the goal keeps becoming, I'm going to keep making it smaller and smaller and smaller until I get down to 1. Now I'm down to 2. Now this minus becomes divide. So here's what my last one's going to look like. It's going to look really weird. I'm warning you. So my add became multiply. My subtract became divide, but we got down to 1 log at the end. Whenever you're asked to condense or write as a single log, that's the goal. We're trying to wiggle our way down to one of these using my opposites. But like we set up above, the big key here is going to be, which is going to make it easier if you follow the order I've got. I'm just going to move this a little bit this way. So here, if you see numbers in front first, if you see coefficients, that's going to want to be what you do first, like we did here with the 1/3, here with the 4 and the 2. If you see plus, those come next, because plus is going to turn into multiply. And finally, if you see minus, that's going to become divide, but you got to go a step at a time unless you are really feeling comfortable with how this is going to end up working.
Just like always simplify the parentheses though.
I can take this further since they're numbers if I wanted to. Like I could do 8 to the 1/3, so that'd be 2 times 3 is 6 divided. I could get it all the way down to 2.
But, so we should.
If you can, you can. I'm not going to press it if you don't. If I can see that you're doing the right things with multiplying and dividing things, that's okay. Once I do these last two with you, yeah, I think doing those others, which I think ends up being 9 total, I don't think it's going to be too bad. I think we're going to be all right.
Can you go back to the notes part?
Yeah, which part? I was going to say, I've got a couple more on here I wanted to do with the expanding, but was there like a...
Wait till after.
Okay, yep, I'll get those back up for you. All right, last couple. So when we get down here, we're actually going to end up doing this in the opposite order. So when we're down here, if it's an option, if it's division that's there, we're going to do the quotient rule first. I see division, it's right there. So when we're expanding, when you see that division sign, that's when we put the new log in here. So divide becomes subtract. Then, if there is any multiplication, we would do that next. But there isn't this time. Like if we were doing 27, there would be, but we're not. So, okay, so no product this time. And then finally, if there are any exponents, those exponents are coming back around to become a coefficient. So that time, we didn't have a whole lot we had to do, but you will end up with more than one log when you're doing these. If you don't, we're in a little bit of trouble. We don't want to be in trouble. And so that would look that way. So the last twist, we've talked about radicals before. You're like, ew, what the heck is this? So remember, when we're doing these, just a little reminder, these are actually exponents, whether I see it originally or not. So let's rewrite this. It's exponent over root and exponent over root. That's actually going to make this a little bit easier once we start working through these. No division this time. There's no fractions. I mean, there's fractional exponents, but not division like these. So none of those. Product we do have. Okay, we're doing m times n. So here, when I go to expand, when I get to the multiplication part in between m and n, we're going to have a plus in there. So multiply became add. And then my last step would be if we have any exponents, and we do on both of our terms. And yes, I should reduce that to 1/2. I just hadn't yet. But I will here. And I get to my solution that way. So, reminder, even though I forgot to put it in the practice packet, I actually remembered to put the key in with the practice online, the keys. So there is a key online for this, but I have it up here too. You could check and kind of see how that is going, or check mine, or take a picture of it, whatever that happens to be. But do be